Truth is that what's going to happen when you have a terminal velocity is it's going to start off at 9.8, but eventually it's going to head down to 0. And at this point, this is terminal velocity. Dude. So you can see that if we look at these three graphs, it's very different than what we're used to. Very, very different. But there's a way to derive an expression for this that describes it in terms of time. And the beginning part of it is actually pretty normal. I mean, it's nothing that we're not used to. So this is a derivation of velocity as a function of time for an object under fluid resistance. Basically, the fluid force is just going to be kV, where it's got some constant. The units are going to be in newtons per meters per second, or newton seconds over meters. Okay, nothing difficult, and this is just going to be the velocity. Well, if we looked at the net force, it's just going to be kV. Oh, sorry. Just move it over here. It's just going to be whatever other force minus kV. Now this force could be anything. In the case of the rock, and that's a little game they like to play on the AP test. They like to say, oh, well, you know, it's sliding down a hill, so now this force is mg sine theta. Or maybe there's some other, like, thing, like a spring or something, kx. I mean, it's a game they like to play. But for us, we're going to go, for our derivation, we're going to use mg minus kv. And that's the net force. And that's pretty easy to understand. Okay. And we know that net force equals ma. So we can say ma equals mg minus kv. I want to point out that when acceleration equals 0, mg equals kv, and v equals mg over k. This is an expression for the terminal velocity. We'll call it vt. And now we got to start separating things out. First, we're going to move stuff around. We have this thing here is kind of goofy. Remember we said that we want it in terms of velocity, so we're going to make this dv over dt equals mg minus kv. We're going to divide all the terms by m, so we get dv dt equals g minus kv over m. Okay. Well, is that right? Yeah, I think it is. So what we're going to do is now we're going to oh, I'm sorry. I lied. I spoke too soon. We're going to divide every term by k to get v by itself. So we're going to have m over k dv dt equals mg over k minus v. So we divided by k. And this is a equals delta, or dv dt. Well, we know this is an expression. This is actually a constant. We can call it terminal velocity. So, terminal velocity minus v equals m over k dv dt. Now we're going to do something that you're normally not allowed to do. We're going to actually say, all right, I want to move all of these v terms to the bottom and move the k terms to the other side. First, I want to reverse these, because I do. So I'm going to multiply both sides by -1. Okay, and this is replace mg over k with terminal velocity. Then we're going to say, we're going to multiply by -1. So now I'm going to have negative m over k dv dt equals v minus vt. Okay. Then we're going to take a look at separating the v's and the t's. So I'm going to actually do something that I'm not normally allowed to do. I'm going to move this over here. V minus vt all times dt equals minus m over k dv. I'm going to move this stuff over here, minus m over k dv over v minus vt equals just dt, and then I'm going to move these things over there. So I'm going to end up with dv over v minus vt equals minus k over m dt. Okay, I'm doing great so far. Now if you look, now I have like a little thing here and a little thing here. So the only way to really reduce this is to actually take an integral. So we're going to take an integral. On the left side, it's going to be from 0 to whatever velocity we pick. So it's going to be the integral of 0 to v dv over v minus vt. And here it's going to be minus k. It's going to be from 0 to t k over m dt. Well, this seems like it's not that big a deal. I mean, this here, the right-hand side, is going to integrate pretty easily. You're just going to get negative kmt evaluated from t to 0, which is just negative k over mt. Okay, so we've got so this side is pretty good, the right side. Now the left side is kind of a mess, okay, because we've got from 0 to v of dv over v minus v sub t. Well, for those of you who have not suffered this much in calculus, there is the integral of dx 1 over x dx actually has a name. It is the definition of the natural log of x. So it turns out that what we're going to do is we're going to replace this with the integral is going to be the natural log of v minus vt evaluated from 0 to v. And this again equals negative k over m times t. And we're gonna, again, if we plug in V for this, again, we're substituting into this guy here. We're gonna have the ln of V minus Vt and it's going to be minus the natural log of 0 minus Vt.